Hello world. This video is the first of the entire Kubernetes series that I am going to host over a period of time, which is pretty soon enough. The purpose of this video is to have a complete tutorial on how to create a personal Kubernetes environment in our local system using virtual machines. And as I mentioned earlier, the agenda of this overall tutorial series is to get to know about Kubernetes from scratch. That means each and every components that Kubernetes have currently and how exactly can we use them. So without further delay, let's start. Now this video is intended for people who all are learning Kubernetes or wants to do any real life POC in vanilla Kubernetes framework. The advantage of this setup is you can have a multi-cluster environment by adding n number of nodes or the worker nodes. It's also for people who want to explore more than Minikube. So most of the training courses you see, they guide people to install Minikube to get started with. And with no doubt Minikube is an awesome tool, but however you will not be able to configure or join multiple worker nodes practically, because it's simply a command line where you just specify minus node is equal to 1, 2, 3, 4. So even if you have no idea about Kubernetes and planning to start, you can consider this setup as a replacement of Minikube. The prerequisite of this tutorial is to have a basic understanding of Kubernetes. Like, you do not have to know all these commands and all. As I mentioned earlier, you can consider, like, instead of Minikube, you can consider this framework. So if you have this setup completed, maybe you can just keep it as a replacement of Minikube. So we'll be needing a preferable operating system, that's Windows, Linux, Mac. For me, I'm currently using Windows. The RAM requirement should be 8 GB because depending on how many master nodes, how many agents that we create, or the worker nodes that we create, we'll be needing RAM. So here, as a standard, what I'm doing is I'm keeping the master nodes and the worker nodes both having 2 CPUs each and 2 GBs of RAM. We should have a processor with VTX support so that we can run virtualization on top of it. And lastly, we need internet connectivity. The software and package requirement for this course would be to have VirtualBox so that we can host our virtual machines on top of it, and you can directly download it from the VirtualBox site, which is currently owned by Oracle. It's a free web tool, so you can download and you can use it. You don't have to pay any extra license cost. The virtual machine operating system, here we are using Ubuntu 2.04 server edition. Why I took server edition? Because I really didn't need any kind of GUI. So it's kind of like a minimal operating system that we are going to get. And we also need SSH client, which is completely optional. And in the next slide, I will show you why exactly I have put SSH client. Now, what are we planning to do? We are trying to install VirtualBox on the local system and create virtual machines on top of it, which are namely our master and multiple worker nodes. Then we are going to install Kubernetes on top of it. Now let me go through a use case that I have actually done in my lab setup, or I'll be doing practically in this exercise. Now I do have a home router network. As you know, like nowadays everyone is having a home router, so you just plug in your internet connection in back of that router and you connect your devices from that router itself. So the cable concept is now, you can say, like, it's gone. Now my router network is currently configured at 192.168.0.0/24. So consider this entire black box here as my local computer, and within that I am hosting a VirtualBox environment. So this is my VirtualBox environment where I am going to create the host. And we are creating, for an example, in this tutorial we are creating one master node and one worker node. So both will be having Ubuntu 20.04, and we are going to create two interfaces on each of these nodes. The first one would be the bridge adapter. By bridge adapter, I mean to say, like, they will be part of your home router network. So let's say your local computer is having an IP address of 192.168.0.2, then maybe master node will also be having 192.168.0.120 and worker node will be having 192.168.0.121, like that. And that's more of like for the ease of accessibility. Here I do have this SSH client, so I can directly SSH to this virtual machines created using this bridge adapter IP address. So I do not have to go and do not have to log into the console of this machine, because that's not feasible according to me. Now, how exactly the master and worker node are going to communicate with? So they are going to have these NAT adapters. So what we will do is, within this entire virtual machines network or VirtualBox network, we are going to create a NAT adapter, and we are going to specify a CIDR range, and we need to make sure that this CIDR range is not conflicting with your home router network. So here we have 192.168.0.0/24 in home router, but if you see in NAT, I have specified 192.168.10.0/24. So there is no chance of conflict. And this is how these two VMs are going to talk to each other. Their connectivity from master node to worker node and vice versa. Now we also need a pod network that we are going to discuss. It doesn't have to be part of your entire network, and we will not bother about it right now. Now this setup we are going to replicate in this tutorial. Let's move on to the next part. So we have VirtualBox installed in our local system. Let me go to that. So I'll go to VirtualBox, and at first we need to create the NAT adapters that we discussed earlier here. So let's go to File, Preferences, and we'll go to Network, add a new NAT network. Maybe let's name it as Kubernetes NAT network. And as I mentioned earlier, we need to provide a CIDR range for this NAT network, and it must not conflict with the router configuration or router IP address that we have configured. So I'll just give it like 192.168.10.0/24. Okay. Now let's create a new machine. So we will name it as cube master. This will be our master node, and just for reference, this is a good place to manage things. So what I generally follow is, for each and every virtual machine that I host, I try to maintain a separate data store so that the backend configurations, backend VM images are managed or stored separately. So here we are going to use this path so that the image created for this virtual machine will be stored in this path only. So we have the type Linux, version Ubuntu. Next, we will give RAM as 2 GB. GB should be fine. And if you notice this part, the path that we mentioned earlier within our custom folder structure using Kubernetes, it's following the same path, and it's writing this VDI in this path only. Okay, now the initial setup is done. Now if you remember, if I go back to this architecture, you will see like each VM should consist of two adapters. One should be bridge adapter, and other should be NAT adapters. So again, let's go to the settings. So this time I'll be selecting this cube master, which is currently in powered off state. I'll go to settings. I'll go to systems. Before I forget, let me just add 4 CPUs here. 4 CPUs. Network. So the first network I'm going to mention as bridge adapter, and it's taking from the same one that's currently configured in my local system. That is a Realtek Gaming GB family controller, which is part of my motherboard. And in adapter 2, we are going to specify the NAT network. And if we select here, you see automatically it takes this one. Now going to the storage, we have to make sure when our VM first boots up, it has to have that Ubuntu image. So either we can choose a disk file, as I have the Ubuntu 20.04 server image stored here. I'll just select it from here. So this is the same image that I had downloaded from Ubuntu site. I'm just making sure that this is part of that optical drive. So now I will do OK, and now it's time to start that virtual machine. Just making sure what exactly is my startup disk. It's Ubuntu. I can confirm that. I'll just hit start. Now you might face this kind of challenge while creating this virtual box. The actual terminal should come as this small. So in order to make sure that we are expanding the window and the terminal is also getting expanded with that, we have to make sure that it's in scaled mode. So if we do this, it will be scaled accordingly. System is booting. English, continue without updating, done. Okay, now if you see here, there are two interfaces that we specified earlier, right? So it's considering the first interface to be part of the bridged adapter, which is a part of my motherboard, that adapter that is within my motherboard. So it's taking the same CIDR range that's within my router network. So it's taking one IP from here, this range, and another one is being taken from that NAT address pool that we have provided. So 192.168.10.0/24. So it has taken 10.4 here. Done. No proxy address. This is fine. No, we do not want to set it up as LVM group. Done. This should be fine. Okay. Done. Continue. Yes. I'll put a generic username. Generic server's name is kubemaster. Done. Install OpenSSH server. Yes, that is the primary reason why we took the bridged adapter. So I will just hit done. I'm not going to select anything because we want to install the minimal. Okay, now this is getting started. So meanwhile, let me pause this video until the installation finishes, and once it finishes I will again resume this. So the installation has finished for kubemaster, and in order to save time I have also created a parallel node, that is kubeworker1, which is going to be part of that entire cluster. So let me just first log in. And we do see the IPv4 address range for these two interfaces, one for bridge adapter and another one for the NAT network. If you remember, we discussed about this SSH client. Now let me open that up so that I can directly log in from my local system so that I don't have to jump terminals. It's 0.141. I'm in. I'll create a separate session for the other node. As you see the host names here, this is for kubemaster and this is for the worker node 1. And this is a good time when you pause for a bit and take a snapshot, and this is the best practice to follow, because after this we are going to have these installations in place. We need to install the packages for Kubernetes or the supporting packages. So if we create a snapshot now, it will be kind of like a fresh Ubuntu box running. So it's recommended to take that. Now before we proceed, as this bridge adapter using which we are trying to log in from this SSH client, this IP is not static. So it's a good practice if you want to save the session in your SSH client for future reference, you can make it static. So for that, I'll just do it for kubemaster. So I need to go to interfaces, and I need to add, and the name of the interface here is enp0s3. I'll just save it. I'm not going to restart it right now, but after this is done, you can maybe stop this box, take a snapshot, and then reboot it back for both of these boxes. Now let's begin with all the steps that we need to now follow to install that Kubernetes master. So we have created the VirtualBox, we have the NAT gateway interfaces ready, we have the virtual machines for both master and the worker node. So let's start with the basic installations. So initially we need to just do one update so that it refreshes properly with the package manager. And I'll be sharing this note in the comment section or description section. Now this will have all these headings like what exactly these commands are doing. So first we did refresh the package repository. Now we are going to have Docker installed on both of these boxes. Now if you see on top, I have mentioned here all hosts. So we need to replicate the same steps for both of these boxes or these boxes that we are going to create. And if you check here, only master host, so these are the commands that we need to execute on the master host. So this is how you can segregate between these two. So the Docker is getting installed. I need to install this transport-https and curl so that all this download from this package manager or the repository is done via https. Now we are going to have the Kubernetes key and repository added on both ends. We are going to have the repository URLs added. To make sure that we are in sync with that package manager, we need to just update once, and then we are going to install all the Kubernetes component, mainly kubelet, kubeadm and kubectl. And by the way, for this worker node, I have added only 2 CPUs, but for master, as you know, I have already selected 4 CPUs assigned to this VM. Now we are locking to a specific version of this Kubernetes framework, that is 1.18.1, and we want to make sure like on the next updates when we do like apt-get upgrade, it does not upgrade the Kubernetes version so that it does not break anything. Now on both ends we need to add one host entry so that it can directly resolve to kubemaster, and we are going to take it from the secondary interface that we have, that is the NAT gateway. So before that, let me install net tools. So the NAT network has assigned 192.168.10.6 for the master VM. So I'll just directly go to this part is done. Now we are going to initiate the cluster. So for our case, I'm going to take this pod network CIDR as 10.10.0.0/16. Now this IP address is never going to conflict with your router or any network because this is completely internal to Kubernetes. So you can assign any IP, but I will recommend if you can. Okay, we got an error. Running with swap is not supported. Okay, so we have to turn off the swap. How we can check the swap is if we do free -m, you can see the swap is currently around like 2 gigs. So I'll just switch off the swap and make sure next time when the host reboots, it's not auto mounted. And I'm going to make the same change there also. Now only on master node I am going to initialize the kubeadm init, and I'll make sure to have the hostname as kubemaster because that is how we registered the master node, and the default port is 6443, and you can specify any port range that you need. Let me initialize it. Should take a couple of minutes to complete, and this is the command that only we need to execute on master. While this installation or initialization is happening, let me walk you through one add-on that we are going to have, which is like Calico. Calico is mainly for managing the pod networks within. So if you directly hit this link, you're going to land on this page, that is Calico, and here you can see how exactly we can download the manifest file of Calico, and similarly we are going to do it here on master node. Okay, so this is done. Let me now download this Calico manifest file, and we are done. Now if I go back to this documentation, you can see that we have to look for this IPv4 pull cider. Let me search it. Here we have let us uncomment it and fill up with that 10 series IP that we specified for pod network. Now we are going to apply, and before that, if you want to execute this Calico YAML, we need to make sure that we are authenticated to that cluster, and this is how we can do it. We have to just have the certificates and all copied. So in my home directory, I'll just execute these commands. Now if I do kubectl cluster info, it's showing me Kubernetes control plane is running at this host. So we are good on this part. So let me now apply kubectl apply -f the Calico configuration, and this is done. We can check the status of the pods, and this Calico pod is currently in pending state. Let's put a watch on this and wait for it to complete. One of the pods are now in running state, that is Calico node. Okay, so all of these nodes are currently in running state. Let me check once kubectl get nodes. So if I do this, I can see my kube master is the only node that's present within this cluster, and the status is currently ready. Now we need to think about adding the additional worker nodes or agent nodes to this cluster or this master node. So for that, if you go back to this initialization step, you will see like there is a command. This is how you can join. But again, this token and all these are generated while initializing the cluster. So let's say when you create a cluster and maybe after 7 days you want to have that. So if you want to keep it handy, you can keep it handy, but it does have some expiration level. So I would recommend to have or create separate tokens and certificate hashes each time when you add a node, so that you do not have to remember anything or you do not have to take a note of that. So let's proceed with that. So we are going to create a new kubeadm token on master node. So we got it, and if you want to list what are the tokens that we have right now, these are the tokens. So this is the one that we have created. It doesn't have any descriptions right now, and this one came with the default bootstrapping when we did kubeadm init, and that's the same thing ending with e4. If we go back to that installation, you will see it's ending with e4, this one. So we are currently going to discard this one, and we are going to go ahead with the new one that we created. Now before that, let us also find a certificate hash, and this is the certificate hash, and this is the command that we are going to execute on the worker node to join. Now we have to fill in the blanks. We have the tokens and all the information that's needed. So it's asking for token, and this is our token that we created ending with 4w. Done. Control plane host and control plane port, we know what exactly this is, so we set the hostname at kubemaster and it's running on 6443. We also need the hash that we have already generated, which is this one. Should take a couple of minutes. Done. So now if I go back to the master node and do kubectl get nodes, we will see that worker 1 has been added. The status is not yet ready, but In some time it should be ready. So both of the nodes are now ready, and we are good to create a new deployment on top of it. So I do have a generic deployment file here that I'm going to create, sample deployment.yaml, and let me just apply deployment created, kubectl get deployments to list deployment right now. So it's saying currently it's 0 by 1. So if I do kubectl get pods right now, so it's currently in running state. Now as of now in this configuration I have only added one replica set or one replica. So let me switch to 2, and this should scale up. Configured. If I check the deployment status now, we can see both of these pods are running, but these are running on worker node. So by default you won't be allowed to create any pods on the master node. So we have to have the node tainted so that it can also host pods within itself. So for that we do have one step. So let me just apply that. Done. It has been untainted, the master node. Now let's change our deployment once again, and let's add it to 4. Configured. And if I do get PO, we can see from 2 we have scaled from 2 to 4 nodes or pods. So now if you will notice that the new 2 pods are hosted, one on master and one on worker, and all are in running stage except the last one, which is soon going to get reflected here in running state. So that's it. We have successfully set up a model Kubernetes cluster within our local VirtualBox environment. You can add additional worker nodes following the same method that we have done. You just have to create the new token and the hash, and you can just add nodes on the fly. Hope this video will or has helped you setting up your local Kubernetes cluster. Please do let me know if you have any issue or challenges while setting things up in this comment section. Also, this is my first video on YouTube. Please do let me know the pointers I need to improve while preparing for the next videos. As I mentioned earlier, I'll create the entire Kubernetes tutorial from basic level to advanced. Again, if you like this video, please do like, share it, and try subscribing to the channel to get regular updates. Thanking you. Goodbye for now.